see this Kickstarter AI, not necessarily, see, I don't want that you should do computer vision track with me or LLM track with me. Okay, that is the objective is like your future learning, whether you learn with me or you do the self-learning or you do program anywhere else, just keep this point in mind, how you should move forward ahead, right? Now you have this foundation, right? How a neural network model works, or basically what is a fully connected layer. So fully connected layer is going to be always at the top layer. We use to refer the term called top layer of any deep learning architecture. Again, it's an interview question. Which is the top layer of a deep learning architecture? Irrespective of whatever the application you use. Say, for example, in one computer vision application, as Gayatri pointed out, say I have a picture. There is one image here. There is a dog and there is a cat is there. I wanted to do the object detection. Okay, you know very well algorithm YOLO. YOLO is a popular algorithm in computer vision, object detection. So here there is a dog and model should say this is a dog. It will label this as a dog. Cat, it will label it as a cat. This is the object detection task. So this comes under the YOLO application. YOLO also, the top layer is nothing but your fully connected layer. Fully connected layer. You know, it is being trained on thousands of classes, thousands of objects like a dog, cat, a car, all naturally available objects in the real world, outdoor world. It's been trained. So different architectures have been trained with the different configurations. So there are so many popular pre-trained models are available for images. So with this foundational knowledge, okay, you can start working with some advanced unstructured data. Particularly, you have to go beyond the tabular data set, isn't it? So your foundation, to get a foundation knowledge on fully connected layer, we have very well used the tabular data set. And also we have used image data set, but the image data set I have converted to a raw pixels. Okay, and we have presented the data like this raw pixel as an input to the model. Okay, like this, we have presented multiple layers. We trained it to 10 classes. That's what we have done. So whether your aspiration is on to develop this idea towards a computer vision track, you have to learn convolution neural network and how you can employ convolution neural network max pool layer followed by flattening layer to classify the image. Okay, not only to classify the image, you can do it for the object detection. What is object detection? In an image, if there is a man, there is a car, your model should give a bounding box and has to label it. This is called object detection. There are so many applications related to the images. So this is one track. Another track is if your organization is working on projects related to text data. Now the recent sensation is the large language models, isn't it? So if you are very curious to learn how to process this text data for various applications. So our current knowledge is fully connected layer. Okay, what I can do with the text data is, if any text data is there, I'm able to say this is the text about a product description of a toy. Suppose I have another in Amazon, I have a product description. This is about a full sleeve shirt. Okay, product about a full shoes. Another one, this is a product description about a kitchen product. I have a description about a product. Okay, various product. The only thing is how we are going to present this text as the numerical value to the model. That is the question mark. Where there is a half a dozens of techniques are there. Okay. In fact, I can extend it to 1 dozen techniques are there. But at the end of the day, you are trying to classify it, right? You have to use a multi-layer perceptron model. That is a fully connected layer. You are going to use it. So remember, whatever the architecture we have learned, which comes under feed forward architecture. Feed forward architecture. That means we also have other type of architectures called as feedback type architecture. Feedback architecture. This is also popularly called as recurrence model. Recurrence means feedback, right? Recurrence model. So the popular recurrence models are recurrent neural network, RNN, and many developments that happen in this track like LSTM model, gated recurrent unit. These are all the development that happen in the recurrence model. What kind of application I should use this model? What kind of application I should use this model? So your foundational module has taught the feed forward architecture. Using this model, okay, you can do only two tasks. What are all the tasks? Either you can do the regressor or classifier. Then what is the use of recurrence model? By recurrence model, you can forecast the next number or you can forecast the next word token. That is what your email, your language models are generative. Why we call this generative AI? Because its output is keep generating the output, right? Tokens. What will be the next token? What is the next token? Next tokens. So generating and creating a sentence is, if you say write a poem, okay, write a poem on the so and so theme, it is generating the output, right? So based on the sequence, okay, the word sequences, it try to understand what should be the next token I should produce, next word I should produce. So to your feed forward model cannot learn to produce the future. Your model can understand the content of the text. What is the content? Based on the content, I can say this is a sports news. Based on the content, I can say this is a political news. That I can say. But feed forward model cannot do the autocomplete. What is autocomplete? I will, the moment you reply the email, I will get automatically try to complete it, right? Complete the sentence. I will get back to you soon. Only the recurrence model can do this. So this is called recurrence architecture. In fact, there is one technology which completely disrupted this idea, recurrence neural network. Till 2016, people were using this recurrence architecture. 2017, there is a destructive paper by Google research team. Vaswani et al. Et al means in the research paper, the team. Attention is all you need. Attention is all you need. This paper has completely changed the recurrence concept to a transformer model. So ChatGPT is using the modern day transformer model. Of course, the transformer model borrows the idea from the recurrence architecture. It's being inspired. It's being inspired from the recurrence architecture. Some modification they have done in this, and they have used this for forecasting problem. Forecasting is a general layman term. I'm using it so that you can easily understand. Okay. Even I have a number sequence. If I have a number sequence like a daily temperature, right? Chennai yesterday temperature was 35.4 degree. Day before yesterday it is 35.3, and that before the day 34.6, and so on. If I have a sequence of daily temperature using the recurrence model like RNN, LSTM model, I can forecast tomorrow's temperature, day after tomorrow temperature. Such models you can use it for the stock pricing, right? Forecast. So this kind, similarly, the same idea you can extend for the text tokens also. You can forecast, and you are trying to generate the word sequences. That's an idea. So it's a completely another different track. So within our boundary to the foundation level boundary, what we are going to do, I have taken different news article, okay, sports, political news, social religion, and some there is a popular built-in data set called 20 news group article, but that is a very large volume of data. To train that large volume, it will, in the live, I cannot train it. It will take 40 minutes to train the entire volume. So what I have done, I have just taken a subset of the data, only 4 classes, using multi-layer perceptron classifier. Already you got familiarized with how to use MLP regressor, right? And then we moved on to TensorFlow Keras framework. Using TensorFlow Keras framework, already we have solved a multi-class classifier problem. Now I wanted to give you a flavor of multi-layer perceptron classifier using sklearn. The reason I will tell you, because using TensorFlow Keras framework, whatever the data preparation part we are going to do, your TensorFlow Keras framework cannot accept it. So for TensorFlow Keras framework, we need to go for more advanced representation. That advanced text representation is called as a word embedding, which is out of the context of our course. So rather what I'm going to do, I'm going to do a very simple representation of the text. What is a simple representation is, assume I have 100 articles. Okay, this is what my training records. Across the 100 articles, I'm going to extract the unique vocabularies, unique tokens. So the words are considered as the tokens. Say this news article comprises, see, leaving all the English stop words. All the English stop word is the article, conjunctions, prepositions. All these things I should drop, and I keep only the keywords, right? Say this is a mostly the news article is taken from the Middle East. Okay, like Arab, party, Middle East, what we call this bigram in the text token. So only the keywords alone will be extracted. Say for example, the first news article 50, the second news article 70. That is a unique vocabulary. Across the training record, let us assume that I have around 15,000 unique words after dropping all the English connecting words, stop words. The unique tokens, what we call token 1, token 2. Tokens are nothing but word 1, word 2, word 3 and all. Okay. So we are going to use some package to represent this. For example, the news article, first news article 1. Say one of the token is about a party, political party. This news article, 15 times that token has used in the news, 15 times. One token talks about computer. There is a science and medicine news article. There is a 0 count on something about the computer. Genetic, it's a scientific article, 0 count. Christianity, social region, is a 0 count. Middle East, 3 times used. Okay. Likewise, this is called count vectorizer. So I have an API call using a count vectorizer. Every article, I'm going to give the frequency of occurrence of these tokens. And that is being weighted. And that is being weighted by, let me show you how do I converted this. See here, I use a count vectorizer followed by another API called TF-IDF transformer. TF-IDF transformer. See, literally this things or comes in NLP course, language model course, but out of my interest, I just give you a flavor of this. Okay, this is a very fundamental process, but there is a lot of techniques are involved in this. The basic level preparation, I just wanted to give you a flavor so that at least you can classify the records. Okay, so using your models, neural network model, we are trying to classify the records. What we have done, document 1, document 2, document 3, and so on. Assume you have 100 news article. Okay, 100 news article. And here you have tokens, word tokens. You have 15,000 tokens, right? assume there is a token name called news. After all these news articles is about the news only. So political news, some are sports news, some are science and medicine news, some news articles are related to religion. If there is a token called news, which is appearing in all, at least one time it is appearing in all the 100 articles, we are calculating something called inverse document frequency term. It's a scaling factor. What will be the scaling factor will be calculated for each token. Each token, the scaling factor will be done. See, one method is you can go ahead with simple count vectorizer itself, just with the count of each word token appear. First document 0 times, 2 times, 1 time, 5 times, 0 times, 0 time, like this, you can go ahead. But mostly this is a sparse representation, isn't it? What is SPARSE? Sparse means it's a very big matrix with lots of zeros. Okay, every article is not going to contain all the tokens, isn't it? Document 1 will hardly, out of 15,000, hardly it will cover 150 tokens. Rest of the tokens are 0. Document 2 hardly covers another 200 tokens. Remaining 14,800 tokens are 0 count. So that's why we call it as a sparse matrix. TensorFlow will not accept the sparse matrix as the input. That is the reason we are going to use sklearn. But to use the TensorFlow framework, we have much better representation of this. That is called as a word embeddings. Word embeddings. Okay, when you extend this knowledge towards your NLP modeling, transformer models and all, when you learn something about this concept called word embeddings. So once you have that representation, your TensorFlow framework, you can able to use it. Okay, once you have got this count, next step, I'm going to calculate IDF score for every token. For example, if I calculate the IDF score for news, how many documents this news token is appearing? All the 100, right? So the numerator 100. Denominator, the total number of documents, 100. So log base 2, 100 by 100. This is the formula for IDF. 100 by 100 is 1. So log base to 1 is 0, right? That means the weighting factor for the news is 0. What it means? News is not a unique token which differentiates that news article, isn't it? For example, a news article which contains a term called a Python. Okay, Python, it's a programming language. Maybe it's a science and science related news article. Python is a keyword which is appearing only in 30 documents. 30 documents out of 100. What is the IDF score for Python? For example, token number 50 is Python, assume. So token number 50, what is the IDF score? Log base 2. Only in the 50 documents, 50 news article out of 100, maybe not 50, maybe I'll take 20. Okay, so 20 news article out of 100, it is appearing. So log base 2, 1 by 5. So we get some weighting factor, say for example around 0.3 something you will get. So wherever you have this Python occurrence happen, see one of the document is a science related document, science and technology news article, where the Python appears 2 times. 2 should be scaled with this IDF score, 0.35 or something. But news is a redundant token, isn't it? News is a redundant token. It's appearing in all the documents. So the token news does not distinguish one news article with respect to another news article. So it is I can say I should give a less importance to this token, right? Which token I should give more importance, which token I should give less importance. That weighting factor, this IDF score is given. Okay. So I'm using TF-IDF vectorization to prepare all the document. We are preparing a matrix like this. And we are presenting this huge number of input as the input to the model. But again, it's not a good strategy. Like for the images, we have taken a very small image, that's fine. 784 pixels. That itself huge. Imagine slightly if I take 100 by 100 image. 10,000 pixels. 10,000 pixels, still technically you can give as an input to the neural network, it will accept. But the question is whether the input is highly informative or redundant. Okay, that is the question mark. So if you apply CNN layer and you can make it more informative features, otherwise here we presented the raw pixel, but still neural network can able to bring a decent level of score. That is fine. Similarly, TF-IDF vectorization it's a one type of representation that is okay, but not suitable for to train a neural network model or a deep learning architecture. Even we have much improved representations, like the way how we use CNN. We have to use some embedding representations for the text data, and you can have more redundant free representations. So that is the use of TF-IDF vectorization. So count vectorization followed by TF-IDF vectorization. So once our numerical representation is prepared, we can feed this to multi-layer perceptron model and we can see the performance. Okay. So that is the task. It's being done in the lab notebook 5. Before that, it's already done. And let me load the best model here. Okay. MNIST raw pixel trained best. MNIST trained model. This time I'm going to rename this as a best. Which model I'm going to load? MNIST raw pixel trained underscore best. Okay. For the summary also, let me take best. So best is saved by auto saving method. Okay. The earlier name was with manual saving. That is the only difference. Now we have directly loaded this. Now I can go for the direct validation. Imagine if you have a bunch of data to validate this. I use MNIST trained model best.predict. All the test record I pass here, I get Y predict value. That Y predict value is one hot encoded probability scores. I apply argmax convert to integer value, and then I plot the confusion matrix and also classification report. Can you see the overall scores improvised to 97? Also, the individual scores also a lot of improvement. Earlier there were not even a single 99, right? The highest was only 97. We have got 99, 99. There are 299. There is 198. Earlier the lowest score was 95. Here the lowest score was 96. So the overall average is improved to 97. So much improved. And also you can cross-check the production data finally here. Production data, obviously, even the earlier model itself correctly predicted. Why not this? Why not the best? Best also will correctly predict this. 3. Right? So this is the validation records and this is the test record or production record. So let us close this exercise. If you have any question on this exercise, feel free to ask me. Okay, now we'll proceed with this exercise. So as I told you, this is part of your sklearn built-in data set. I'm going to load this fetch 20 news group data set. See, it's a simple task. Once the data preparation is done, it's your regular neural network. And so hardly take just 10 minutes to navigate this node. So only the data preparation part is quite new for you because you're not familiarized with the text data. Look at this. I'm going to take the subset of this, but original, you just Google it for 20 news group. You can see all the classes, 20 classes. I take only a few: politics, Middle East politics, in the sports, baseball, science, medicine, and social religion. So when you load it directly, you can pass the subset. If you don't pass the subset, the entire data will be loaded. Okay, only these 4 class subset will be loaded. And can you see fetch 20 news group subset train? I'm saying the train subset and which class you are loading, that is being specified in the category. So this is the train subset is loaded and the entire test subset is loaded. So the test record, you can use it for the validation. This is for the train. So both I'm loading. Let us cross check the size. So even this 4 class itself, we have a huge number. It's not simple. Look at this, 2,354 documents. Validation record, 1,500 documents. So if you load the entire data set, so it's more than 10,000 articles. So to training, it will take minimum 30 minutes to train all the records. So we'll take a subset of it, 2,354 with 4 classes. If you wanted to check the target classes, 20 train.target, if you type, you will get, they are numbered as 0, 1, 2, 3 as the form of integers, 0, 1, 2, 3. If you use TensorFlow Keras framework, I should do explicitly one-hot encoding. Since this exercise we are going to use sklearn MLP classifier, no need to use the one-hot encoding because internally it will do it for us. But you may ask, sir, why TensorFlow Keras framework we are not using it? Because the data preparation part is out of the scope for us, right? It is beyond the scope of our foundation model. You have to learn some advanced technique to do the data preparation better than this TF-IDF vectorization. But still, TF-IDF vectorizations are being popularly used for some other applications like recommendation systems and all. We are using it in the Amazon, Flipkart portal and all, right? Still, they are using TF-IDF vectorization. There, only the distance calculations, they are going to use it. The customer who purchased this product also purchased this. Or whenever you see a product description, it is going to show you other similar products, right? Whenever you see a product, say for example, a mobile phone, the moment you start reading the description about a particular mobile phone, you see the description, features and all. Below it shows other similar products, right? That is what its recommendation system, it's work on the distance. Out of the entire training corpus, your document is represented as TF-IDF vectorization and each and every other models will be there. And calculate the distance, which is the closest to 10 records, closest to 5 records, it is showing the display. Also, it gives for association map, what we call as an associative role mining, associative map. So customer who purchased this mobile phone also purchased the screen guard plus this cover. So this is called as a market basket analysis. For market basket analysis and a recommendation system and all, still this technique is popularly used, but not for a text. If you wanted to use it for neural network, for high level modeling, nonlinear model and all, this representation is not sufficient. That's what I'm trying to convey here. But still, we can able to supply this as an input to MLP classifier, and we are going to see how good our model is going to recognize the news article. So target alone, if you use the method, it will show you the label number. But target names, if you type, okay, how I map this 0 belongs to sports, 1 belongs to, just by printing the first few records. Not a big deal. See, you print first to 5 records. First to 5 records randomly. 33011, right? You can easily understood which class. Similarly, in the names also, you print first 5 records. What is the label number 3? It is sports news, right? So label 3, 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Okay, this target names will give you the unique classes. Okay, it is giving only the unique class. So I manually cross-checked few records. Say for example, I need to understand the first record is 3, 20 train.data, third index. So homeopathy, medicine, right? So label 3, 0, 1, 2, 3. See, this is index number. This is actually label. Okay. The 0th index, 0, 1, 2, 3. That means the third index, the index location, if I pass, the label number is 1. Okay. The label number 1 is science and medicine. One I'm passing the index, another is the label. Don't get confused with the index and the labels. So likewise, I cross-check. This is what the sanity check we have to do it. And this is for my self-reference. I just mapped this. How model has taken the label for it. Because we have taken the subset, we have to make sure that which label corresponds to which news article. So when you display first to 5 records in the target, what are all the labels first to 5 record? 33011, right? 330. If you wanted to know what is 3, you have to see the first index. What is the first index? 0th index. 0th index is 3. So no land for peace, no negotiation. It is a Middle East war, right? So it is a political news. So label 3 is a political, Middle East political news. Already we decoded label 1, which is a science and medicine. Now we have to see who is this guy. 0, 0, 1, 2, right? Index 2 I need to see. Index 2. It is about fan of the above mentioned band. Yeah. 0, 1, 2, 3, 4, 5, 6, 7, 8. Maybe if you don't get clarity, maybe you can cross check with another record of similar category. So it is about the baseball sports tournament happening across different universities and all. So 0 is about the sports news on the baseball. Few more samples also if you cross check, still if you couldn't comprehend. This is just for our self-reference. Okay, if you want to have a very detailed, now it is like clumsy, right? All these news articles are received through email. Okay, you can split based on the new line and you can print the clean records like this. So from which, from address, okay, and this is the content of the news article. So instead of simply 20 train.data square bracket 0, okay, you can print it like this, proper format. Suppose the 0th index. Okay, this is the another way to fetch the label name directly. See, for example, the first news article, 20 train.target square bracket 0, target square bracket 0, third, right? What is third? Label 3 is a political, right? 20 train target 0th index. 20, sorry, it is not. Correct, 20 train target 0th index. So 0th index 3 will see what does the 0th index, the target name is returning. Can you see? Political news. This is either manually you can cross check or you can call 20 train target names. And inside the target name, what you pass? The index, 20 train target square bracket 0. So the first label number 3 is political news. Again, second record is a political news. 0, okay, 0 if you couldn't comprehend, better you pass that to the 0, 1, 2. The index number 2 I should pass. Index number 2 if you pass, we can get the class name. Okay, sports baseball. Also, one more we verified manually, right? Index number 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 8th index also we check here. 8th index also should be sports baseball. Sports baseball. So we cross-check the labels. And also you can print the first 7 records, the label. Politics, politics, baseball, science, medicine, science, medicine, science, medicine. So we have got 3, 3, right? 33011, right? 33011. So this is 3, 3, baseball 0, science medicine 1, 1, 1. Again 3. This is 4. Sorry, 2. So starting with 0, 1, 2, 3. So totally we have 4 labels. So we have very well understood the data structure and also the corresponding label numbers. Okay, after investigating this, I prepare the data. This is what the data preparation. I use count vectorizer and TF-IDF transformer. First of all, you have to initialize both count vectorizer as well as TF-IDF transform. There is also one recent package available, TF-IDF Vectorizer. If you use TF-IDF Vectorizer, you don't need to do this as a two-step process. Here we are doing it as a two-step process. Look at the first step. I pass this onto the count vectorization. And then I apply TF-IDF transformer, right? We have also have TF-IDF Vectorizer package. If you use that, you can skip count vectorizer. Directly, you can apply fit to transform. Just one line is sufficient. The last line alone is sufficient. There you can pass your original data. 20 train dot data you can supply over here. But here we are doing it indirect two-step process. See, sometimes people would like to work with the count value without weighting. If you wanted to work with weighted score means they will use this. Okay. If they use with only count, they can use this variable with weighted value. This is weighted score. This is unweighted. For that purpose, it is being shown as a two-step process. It's up to you. You can try with this data and how model performs. Otherwise, with the scaled weighted score, how the model performs, you can compare for that convenience. Otherwise, I would recommend the scaled version. Okay, that will be more appropriate. So all the training record, we have applied a TF-IDF transformation. Look at the size is very, very huge. How many records we have? 2,354 documents. How many unique tokens we have? We have got the unique tokens, 36,786 unique tokens, which is very huge. This huge sparse matrix, okay, we cannot feed the huge sparse matrix to the TensorFlow. But you may ask, sir, TensorFlow Keras framework has been used to handle the large volume of the data. Of course, you can use large volume, but with meaningful data. We are presenting the large matrix with redundant information. You are feeding something like a large columns with so many places are zero. We call this a sparse matrix. Non-zero elements are coming there. Very few values like 5.2 here 7.2, 3.2. Rest all other places are zero. This sparse matrix, it won't recommend. Dimension doesn't matter. The sparsity is the issue. That is why we wanted to solve this using SQL and MLP classifier. MLP classifier does not have the constraint. Similarly, my test record also I convert to this, and you can see it is 1567 record, because your test record vocabulary will be different from the training record vocabulary. 3893. Can you see if I check the type of my TF-IDF representation, it shows It is a dense sparse matrix. Okay, this is a dense sparse matrix. Okay, now we'll use our MLP classifier. Earlier we used MLP regressor, right? We are using MLP classifier. I just use just 2-layer. Like the way we tuned it, first I started with 1 layer with less number of neurons, gradually increased it. With the 2-layer with these many neurons, I have got some reasonably good result. See, here we have got TF-IDF transformer, right? This TF-IDF transform is already fitted over here on the train records. You can directly use the TF-IDF transformer for the validation record. Okay, here we are not going to fit only transform. That means for the validation record, even the validation record has less number of vocabulary. The other spaces, it is going to append with zeros to make the dimensions same, right? Literally, the model should expect 36,786. Ask about where are the other inputs. Basically, we are going to feed 0 to it, right? So I update my test record also. So my model is trained, right? My model is trained. Now I wanted to validate my model with the test record, the subset test record. The test record also going through the process, but only difference is I don't apply fit transform, only transform. So this is fundamental thing, you know it in any machine learning model. During the training data, fit transform, but on the validation data, only transform. That means the training data statistics is used for the validation data. So validation data, we don't separately calculate statistics or anything else. So the same strategy, we use it for standardization and scaling also, right? If you apply standard scaler on the training data, fit transform, but on the validation data, direct transform. If you apply fit transform also here, that is what we call as a data linkage. So you are trying to take a different statistics from the validation data. We should not do that. So your test data also prepared to the equal number of columns. Sorry, same 3893 here also 3893. So earlier I have taken different number of classes. That's why the number shows different. I have taken 5 classes. That is reduced to 5 classes. 4 classes I reduced. So from 36 tokens, it reduced to 30 tokens. Now, can you see the trained model? I'm going to use it for predicting 1567 news article. I have predicted the labels. So earlier I ran this by mistake. I should not run this. For only training record this. Okay, let me update this again. Okay. Just to compare the result, I have used it, but you should not run both. Please comment this in your notebook also. Please comment this. What will happen if you apply fit transform to show that I have done this, but strictly only transform, not fit transform. Now I can use the trained model. Okay, for safer side, I have not modified anything on the training record. Okay, we'll directly go for prediction. So we have got predicted value, and you can use the metrics to see the overall accuracy. So the targets are available in 20 test target, and the predicted score overall average is 96. And you can print the classification report class wise, each class 98. The highest one for sports. Okay, sports, then science, social, religion, and political. Sports, science, religion, political. Okay. So political news second highest, science is the third, and the least is 95. Overall average is 96. So 2 is the least. This 2, yeah, 2 is the social religion. So this is for the bunch of validation record you are validating. But if you wanted to take it like a production, okay, assume this is a production record. I just randomly gave a few example sentence, test document. Okay, the first sentence, God is love. I think that ketosis can occur in lesser degree is one of its. So it is a science article, right? The third record I give baseball match with high score player from Israel and Arab audience and few Middle East. So 3 sentences I just give, which goes into the count vectorizer, followed by TF-IDF transformer, only dot transform. See here, in both cases, I'm not applying fit transform, only transform. So your production data go through the data preparation part. It is converted to what? It is converted to three record. How many columns? 36,786 tokens. Out of 36,786 tokens, how many tokens hardly we have? 1, 2, 3, 4, 5, 6. And of course, this TF-IDF transformer will skip these stop words and all. So after leaving the English stop words and all, 1, 2, 3, 4, 5, 6, 7. Hardly we have around 20, 30, maximum 30 to 40 tokens. Think about it, remaining 36 plus 1000 tokens or 0. It's a sparse input we are giving to the model. But still our model is making a reasonably correct predictions. It's predicting 210. The first news article, it says return label 2, which is a social religion. 1 is science. Third is a sports. If you don't understand the label, try to decode the label using target names. Okay. The predicted test doc. The predicted test doc, I just loop in, and doc will refer to the test doc, and the category is referring to the label. And you can print the original sentence and what is being labeled. God is love is being labeled as social religion Christian. A ketosis news article is about science and medicine. Baseball match is about sports news, right? So it's neural network model. Even though you present the input in the form of a sparse matrix, still it is doing a reasonably good job in spite of the redundant information. Just think about it. If you give a precise information, how good your model can do the task for you. So that is the strength of the neural network. Even in spite of the noise, our model is doing a reasonably 96% good job. Accuracy, overall accuracy. So for practice, what I suggest you, at least you increase one more class. Okay. You go to the documentation page, just you type 20 news group documentation. In Google, if you search, you will get it. At least include one more news, make it as a 5 class. Okay, little bit you tune the architecture and see the performance for the 5 class. And randomly you give the 5th class news article as the input to the model and see whether your model correctly predicts or not. In the same manner, you utilize the notebook number 4 to randomly feed some random integer to the model. Download some pattern images JPEG files and feed it to the trained model and see how good your model predicts the patterns. So we concluded. I would like to quickly summarize the key idea and the objective of this foundation module is to give you a solid foundation to a feed forward neural network architecture, which is going to be one of the heart of every modern day applications. Okay, you take any modern day, if you take a chat GPT, if you ask, sir, feed forward neural, this, whatever the multi-layer perceptron model you discuss, is it being used in chat GPT? If you ask, I will say yes. But where? Only in the last layer, top layer, it is being used. How it is being used? The trained records will be like a millions of vocabulary, right? Whatever we have seen is just only 36,000 tokens for the last exercise, but billions of tokens. Out of the billions of classes, your top layer, the last layer, is going to predict which word will gain the highest probability. That token will be predicted by the model as the next word. And how the model generate the next word? When this sentence is given as an input, I will get, okay, when this is given as an input, what is probability of y cap given, I will get, and out of the several billion token, which token got the highest probability, the token back got the highest probability. So that will be recursively given as an input. Now I will get back what is the probability of y cap given, I will get back. Now out of the several billion tokens, which token got the highest probability, I will get back to you soon, right? So, but for language models, they don't filter the English stop words. But for product classification or news article classification, English stop words is not communicating the meaning of the product or the news article, right? According to the context, the treatment will change. For the language model, large language models and all, we'll keep all the English stop words because we need to have all the connecting words, meaningful sentences. But on the other hand, if you prepare the data for document classifications, we need to filter the English stop words. So that can be controlled using your TF-IDF and other vectorization. So your feed-forward neural network architecture is called as a fully connected layer, which is being anonymously used in all the modern day application. If you talk in terms of a computer vision task, YOLO, it is being used in the top layer. So your Kickstarter Foundation model has given the core model. You can take it to any application. Only thing is, application to application, your data prep part is going to be unique for you. When you deal with image and videos, what is the data prep part? You have to learn further convolution, max pool, flattening, and also you need to get exposed to different pre-trained model, which is developed using CNN architecture. Once you get exposed to it, you can go in this track. You can extend the idea of CNN-based model to object detection, semantic segmentation, face recognition, these kind of tasks. Similarly, when you deal with the text data, you will be learning word embedding and other advanced representation, numerical representation. You'll be using transformer model and so on. When you deal with the time series data set, you have to work with convolution 1D. Likewise, max pool 1D. You have to do the data prep. And at the end of the day, time series data, whether you want to classify or you are going to forecast according the respective model you have to choose. Only classify, you are fully connected is okay. If you wanted to forecast, you need a recurrence model like RNN or LSTM model. So what you are going to do with the data, that is going to decide your algorithm. First of all, you need to understand what is your client requirement. If you take a text data, you wanted to classify or you wanted to forecast the next token, generative model. If it is a time series data, again, you wanted to classify to male speaker and female speaker, or a time series data like a daily sales or a stock market trading value. You wanted to forecast the next few values. it comes under a forecasting problem. So with this foundation, I strongly recommend you to move forward, whichever the field you are interested in. If you are interested in images, you move with this track. If you are interested in a text, you move with this track. So you take a specialization. So a solid base is given to you. Taking the specialization, you can easily navigate, because the solid foundation is what very crucial in understanding the advanced applications and all. Particularly when you are moving, you are changing the job and you are attending the interview and all, this core foundation, the concepts, whatever you have learned, is going to definitely help you to crack the interview. Definitely foundation concepts, nobody is going to ask you any questions beyond this. Okay. And definitely when you are going to land in a particular job related to LLM or computer vision like that, obviously that domain specific questions they'll be asked. So further, you have to upskill any one of this track, whichever the track you are interested in. You can choose the track and you can move forward. So with this note, I'm closing this. So definitely you have a cumulatively more than 12 hours, I guess, 13 or 13.5 hours. Revise it. This recording is going to be available with you for another 1 month. So whatever the topic, if you have a doubt, revisit the video, play back the recording, pause, and then try to comprehend it, again play back. That is the way you have to back and forth. You have to go back and learn it. Do a few exercise hands-on so that you will get some idea. You try to tune it. Once you started to tune it with the new data set, it will be more fun. You will get to know that, okay, you will start with one layer and gradually increase the layer, how the model reduces the losses and all. To see that, it'd be really fun, and work with different variety of data and see how familiarized you become with the foundation concepts. You will be super confident with the base, and then you think forward, move forward, what application you wanted to take it forward. If you have any quick questions or general, if you wanted to ask anything in general about your career or whatever it is, you can feel free to ask.